going to take another look at how to solve systems of equations with matrices. We're going to use a little different approach. Let me kind of talk you through it here. What we're going to do is we're going to create a system of matrices where here's our matrix that we're going to take. So we're not going to augment them, essentially. What we're going to do here is I'm going to have a matrix that is just the coefficients of the system. I'm going to create this variable matrix that's going to be just the x's and y's. And then over here is going to be our output here, which is going to be our solution matrix. Let me set this up and it'll make more sense. So what we're going to do here, let's create a matrix A that's going to just be the coefficients. So 3, 8, 4, and 11. Okay? Now we're also going to create a matrix which is the variables. Now if you multiplied row times column, you would create 3x plus 8y. Do you see that? If I did this row times this matrix I've created, I'd get back to what I've started. It'd be 3x plus 8y. So that's the goal. Then you could do 4 times 11 times xy, you'd get 4x plus 11y. So we're not augmenting the way we have done before. We're making a coefficient matrix for the left, a variable matrix with the x and the y, and then we're going to create something called B here is going to be our solution matrix 5 and 7. Now again, we could have done this with the previous approach. We could have augmented a matrix and done this, but let's see the logic of using an inverse to solve a system like this. So now what we have is A times X equals B. So how could we solve this? Well, here's the trick. If I multiply A times its inverse, that's going to create the identity matrix. And the identity matrix times x is just going to get x. It's going to get us right back to where we started. So here's what I'm saying. If I multiply A by its inverse, I'm going to have nothing but x on this side. But if I do something to one side, I've got to do it to the other. So if I also multiply the right by A inverse, then what I'm going to get, I'm going to create x on the left, and my solution set is going to be on the right. Let me see if this makes sense to you. So the first thing we need is we need to just find that inverse. So here they've got the same system. Yeah, so here's our equation. But it's really now A times x equals B. All right, so what we need is the inverse. Now here they are finding the inverse. It was a 2 by 2, so they're using that formula, but I would have just used my calculator button. Here's my inverse. 11, negative 4, negative 8, 3. So if I multiply, so here's the logic of it. If I multiply the left by the inverse, the a's are going to drop out. It's going to create the identity matrix, which is nothing. It'll just get us x, y. Now, if we do the same on the left, now the order matters. It needs to be, if I multiply on the left by a inverse there, I need to do the same over here with the a inverse on the left of the b. So the order matters there. So if I multiply a inverse times a, it drops out. I get x. If I multiply a inverse times b, the only thing left is the solution set. I've got it down to what x and y must be equal to. So hopefully the logic makes sense. The inverses drop out. There's nothing on the left but the variables. What's on the right, if I multiply that by a inverse, what's on the right, the only thing left must be the solutions. So let's do it again. So we're going to set this up here. This is what we've got. A is the coefficients, x is the variable matrix, and then here's my solution matrix. Okay, so now we need to find A inverse. Especially in a problem like this, I would just do A inverse on my calculator and I would get there. But what they're doing, remember, is that approach where they're augmenting it with an identity matrix and then they're flipping the sides. So they're solving it all the way down to where they didn't go all the way. Yeah, they did now. Okay, so they've taken it all the way down. On the left now is an identity matrix. On the right now is the inverse. Remember how that process worked? So hey, here's A inverse. Now, if I multiply A inverse on both sides, I'll have nothing left. This is all going to go. That's just 1. And what's on, nothing left over here but the solution, or the variables. And what's on the right, if I multiply this by A inverse, what's on the right will have to be the solutions. So another approach to solving a system. So here they go at it. They're multiplying both sides by the inverse. So this is going to just drop out. We know that. and so you're going to have nothing left but x, y, z. So really basically all you have to do is multiply the matrix on the right by A inverse, and you've got your solutions. So they're just doing A inverse times B. Again, I would be okay at this point with using your calculator to do that. And so what's on the left now is just the solution matrix. So x, y, z equals 1, 2, 0. Okay, so sorry, I'm doing the augmented approach is the easier one, and I'm doing that. Okay, so here are my matrices. This is a 3 by 3, and on the right is my solution matrix. So I need to find, this is A right here. This is matrix A. So if I find A inverse, I then multiply A inverse times that B, 0, 8, negative 2. So I would do this on my calculator here. I would find the inverse, multiply that by matrix B. I would have created a 3 by 1 for B. Multiply those together and you're going to get your solution set. I think I just did it, yeah. So I'm going to just give you the solution. Check yourself on this. So I multiply those together. A inverse, which I just find by putting in A, hit the inverse button. That's A inverse. Now, the A, or actually on your screen you could do this all at one time. If you've got everything and you've got A and B entered in your matrix area, just do A inverse times B, so matrix, you got to go in there and go to the names and bring B to the front. Hit enter, it'll do it all for you in one shot. And the values you have are x, y, z. That's what you have. And so you have your solutions. Again, either approach would work. You could have just done this with an augmented matrix, but the logic here of how to solve a system this way is pretty clever, and it shows the value of the inverse matrix. Oh, I thought we were done. Oh yeah, so they're just telling us how to do it with a calculator, but I've already been doing that. So you would create A, you would create B, and then all you really have to do is literally on your calculator A inverse times B, and you'll have the solutions. There's X, there's Y, and there's Z. All right, I hope that makes sense.